Welcome back, folks. In today's class, I'll talk about the true weight and the apparent weight. So if I start with the true weight simply Fg, which is equal to mg, and true weight always acts in the downward direction because acceleration due to gravity always acts in the downward direction. So let's say my body mass is 80 kg and I'm standing on this planet Earth. So Earth is trying to pull me towards itself with the gravity of 9.81 and my body mass is 80. So the Fg value will come across as 784.8 newtons. So that's also the true weight. Now, when we write down the equation F net in the vertical direction, F net is equal to Fn, which is the normal force acting in the upward direction, minus Fg. Again, as I said, because Fg always acts in the downward direction, so I've taken it in the with the negative sign. Again, I'm just giving you a recall that I'm not going to put in the negative down here because I've already taken a direction down here that the acceleration due to gravity acts in the downward direction, so the force due to gravity will also be in the downward direction. You consider once, you don't take it for both of them. You don't consider that you're going to take the acceleration due to gravity as the negative and then on top of that you put the force value as the negative also. That's going to change the answer then. Okay, so hopefully that you understand now. And now this is the equation I've written. Now if I wanted to find the normal force Fn, then it will be F net plus Fg in that scenario. And this normal force, if I reverse the direction of the normal force, then it will become the parent weight. So negative of Fn will become a parent weight. Okay, so that's the definition of apparent weight. Now, where this is useful, so for example, if you are in an elevator, if you are moving up or down the elevator, you will feel lighter or heavier depending upon whether the lift is moving up or down. So that's where the apparent weight comes into the picture. That's as I said, when you are in a lift or when you are standing in a rocket. So I'm going to take an example on the true weight and the apparent weight. So with that, hopefully you'll be able to understand this concept in a better way. So let's say there is an astronaut, the weight of that, not the weight, the mass of that astronaut is 60 kg. And also given to me that he is trying to land on the surface of Mars. Okay, so if the Mars surface, if it is given to us, it is a Mars surface, then it will be equal to the acceleration due to gravity we have to find on the Mars surface, G value. So G value is on the Mars surface, it is 3.71 meters per second square. Again, I've told you, but in past I've given you the formula to calculate this also, how you can calculate it. So what you're going to do is G value is gm1 divided by r square, and G value is constant 6.67 times 10 raised to power negative 11 multiplied by the mass of the Mars, whatever the mass is, divided by the radius from its center. So whatever that is, square that, and you should get the G value for any planet. So right now we are talking about the Mars. So I'm gonna write down the G value for the Mars surface, that is equal to uh, 3.71. Just to let you know that the mass of the Mars is 6.37 times 10 raised to the power 23, and the radius of the Mars is 3.43 times 10 raised to the power 6. Okay, so that's gonna be the acceleration due to gravity. That's how you will be able to find out. All right. Now, once we figured out this value and what else is given to me, so there is a rocket, as I said, which is trying to land on the Mars surface. So I'm going to design it here. So this is a rocket which is trying to land on the Mars surface. All right, and it's slowing down with an acceleration of acceleration of 11.1 meters per second square. It's slowing down because it's moving, it's trying to land. So this value, it is acceleration value will be in which direction? Acceleration value will be in the opposite direction. So this acceleration is opposite. It's same as when you are applying the brakes. So if you are moving forward and you are applying the brakes, acceleration will be in the opposite direction. Now you are trying to slow down, it means you are applying the brakes, you are moving in the downward direction, applying the brakes, acceleration will be in the opposite direction to that. Okay, so I'll take this value as negative. And now I wanted to find two things. What is the true weight of the astronaut and what is the apparent weight? True weight and apparent weight. Apparent weight. These are the two things I'm looking for. So true weight is equal to Fg, which is equal to mg. So I'm gonna say if the mass is 60 kg, 60 times 3.71. So if I multiply these two numbers, 60 uh, 60 times 3.71, that's gonna give me 222.6 222.6 newtons. The unit of the weight or the force due to gravity is same, that is newton, and that will be in the downward direction. Okay, so basically weight, whenever we're talking about the weight, it means same as the finding the force. Okay, now I wanted to find the parent weight, so I'm going to write down the equation, that is F net equal to F A Fn, shall I write, plus minus Fg. Because the acceleration due to gravity I always acts in the downward direction, so I'm only going to take the negative direction here, and then I'm looking for Fn value. Net value will be equal to mass times acceleration, and this value we've already figured out, 222.6. Mass times acceleration, 60 times 11 point, it was given to me 11.1, uh, which is in the which is opposite, so upward. So I'll keep it, uh, sorry, I won't use the negative here because this force is upward, so my apologies, correcting it up. It's going downwards, but the acceleration due to gravity is in the opposite direction. In this case, opposite is up, so I'll keep it as positive. So this will be 60 times 11.1 Fn, and minus 222.6. And if I multiply 60 times 11.1, that's going to give me 666. 666 equal to Fn minus 222.6. This is going to go on the other side. 666 plus 222.6 equal to Fn, and then I will add both the numbers, which will be equal to 888.6 Newton, which is the normal force. And now I wanted to find the parent weight. Parent weight, that will be equal to negative of 888.6 Newton. Okay, that's how you're going to find the parent weights. And again, I'm going to take another example so that you can understand it clearly. Now, let's say it's the same rocket is trying to lift off from the surface. Okay, if it is trying to lift off, then the acceleration will be upwards. So same as when you're trying to drive a car, if you are accelerating it, the acceleration will stay as up in the forward direction. So if you noticed, whether the rocket was trying to land onto the ground or whether the rocket is trying to take off from the ground, acceleration has to be up, always up, so it will always be positive. When I'm saying acceleration, I'm talking about A, I'm not talking about the acceleration due to gravity, G value, that is always down. Okay, so F net is equal to Fn, and plus minus, I'm going to use the minus because Fg is always down, and this is Ma equal to Fn, same old story, minus this weight does not change, and this value was 300 and 222.6. So 222.6, and then I'm gonna find this number. Let's say acceleration this time around, I'm gonna take a random number, 6 meters per second square. So this will be 60 times 6 Fn minus 222.6, then 360 equal to Fn minus 222.6. This is going to go on the other side. 360 plus 222.6, that's going to give me the apparent weight. So if I add these two numbers, the answer will come out to be 582.6 Newton. And that is that the apparent weight? No, that is the normal force. Negative of normal force is apparent weight. Apparent weight. So that will be 582.6 negative equal to apparent weight. And that I can also write it as 582.6 down. Unit is Newton. I'm writing on this side. This is the units. So hopefully you were able to understand how you can approach the questions on the apparent weight. And I'll see you with another video. Till then, goodbye.